Hello everyone. Today we are going to discuss capture mode of CCP module which is available inside PK18F4550. In the last session we have gone through PWM mode of CCP module for PK18F4550. So today we will discuss capture mode. Okay, let's start the session with the objective. Objectives are first is to study on chip CCP module, CCP section of the PK18F4550. Then the timers which are required for capture mode and compare mode that we will study in details. All of you know that we have started the CCP module from the last session. First, we have gone through PWM section of PWM module or PWM output of PK18F4550 CCP module. Okay, all of you know that these features of CCP module we have already discussed, but again we will discuss it. Generally, PIC18 series microcontroller has 1 to 4 CCP modules. Okay, CCP is nothing but compare, capture, or capture, compare, and PWM mode. These three modes forms CCP modules. Okay, so for if we talk about PIC 18F4550, okay, in PIC 18F4550, two modules are available for CCP section or CCP module. So two more CCP modules are available for programming for the user. Okay, so in which you can or user can program the microcontroller for capturing the events, comparing the two values, or generating the pulse width modulated output for driving the DC motor or for driving the LED displays. So all these CCP modules has resistors for capture and compare mode. Timer 1 and timer 3 are used, and for PWM mode timer 2 is used. Okay, timer 1 timer 3 can be programmed as a 16-bit register for storing the values, okay, which are generated or which are captured in capture mode, as well as interrupt which is generated in compare mode that will be stored in these 16-bit registers. These are 2 byte registers which can be programmed as a 8-bit or 16-bit registers. Okay, so to control the CCP operation, capture, compare, and PWM, these control registers are available inside the PK184550, that is called as a CCP1 con register and CCP2 con register. Okay, so these registers uses 8 bits for controlling the operation of CCP module. Now, as a data register, CCP has two registers, okay, which are 8-bit wide. So total 16 bits are available for storing the values. So these registers are CCP lower byte register and CCP higher byte register. This is for 1 and 2 respectively. So CCP1 module will have CCP-R1L lower byte register, and second register is CCP-R1H higher byte register. Okay, so this CCP module uses timer 1, timer 2, timer 3. As I told you, this capture and compare mode uses timer 1 and timer 3 registers, and PWM uses timer 2 registers. All of you know that RC1 and RC2, these two pins are allotted for CCP module. Okay, and alternative to RC1, it is RB3 is available for this CCP module. Okay, so these CCP modules can be configured in capture and compare mode by using CCP1 con register and CCP2 con register. These are the control special function registers which are available in PIC18F4550 to avail the mode of operation in capturing and compare. Okay, so to have or to generate this kind of modes or to work with this kind of modes, PIC18F4550 has one particular flag bit, that is CCP1 interrupt flag bit. Okay, so this flag is used for showing the status of capture mode and compare mode. Okay, so timer 1 and timer 3, all of you know that that is used for storing the values. Okay, or these registers are used as a timer for CCP 1 and second module. Okay, or CCP 1 or second CCP second module. Okay, so accordingly we need to configure these timer 1 and timer 3s for capture and compare mode. These are the applications of CCP modules that already we have discussed. Okay, so capture mode can be used for period measurement, pulse width measurement, interrupt generation, event counting, time reference, duty cycle measurement. Same way, compare mode can be used for generating single pulse, train of pulses, periodic waveform, start of ADC conversion. You can start with this compare mode. When two values are equal, they become equal, we can start ADC conversion, we can send start of conversion pulse for ADC module, and you can use this as a time reference. In PWM mode, already we have discussed, this particular mode is specially designed for driving the DC motors. Okay, which can be connected to PIC18F4550, as also various types of displays can be driven by using PWM output. Okay, so these are the applications that you should remember from the oral point of view. These questions may be asked at the time of oral examination or practical examination. Okay, so if we talk about what is the capture mode, then this is the block diagram simply describes the working of capture mode. Here you can see unknown signal is applied, or we can say that clock pulse is applied. We can configure this CCP module in capture mode. Okay, for timer we can use pre-scaling options, 1:1, 1:2, 1:4, 1:16. Okay, so these pre-scaling options we can use to increase the measurement period. Okay, and here we can set the falling edge and rising edge for capturing mode operation. Okay, so that means what event which is happen, okay, or that will create a clock, or that will generate an interrupt signal in capture mode on either falling edge or rising edge. Okay, so here you can see this is the falling edge and this arrow is wrong, this should be in downward direction. So this should be in downward direction, that is falling edge. So either falling edge or rising edge is used for capture mode, capturing the unknown signals or capturing the events. Okay, so this capture mode uses this CCPR1 lower byte register and higher byte register for storing the values. Now, whenever event occurs, okay, at the start we will turn on the CCP module in capture mode. Okay, and whenever events happens or event comes, this particular register stores the value, okay, of it into these two registers. Okay, so whenever we turn on this capture mode, timer 1 or timer 3 starts. Okay, and upon every clock pulse, these timers will get incremented by 1, and whenever event occurs, then timer 1 and or timer 3 will store, or this PIC18 microcontroller will store the content of timer 1 or timer 3 into these two registers. Okay, so if we are programming in 16-bit mode, then 16-bit value of timer 1 or timer 3 will be loaded into this CCPR lower byte and higher byte register. Okay, so that we can measure period between two events. One is start and one second one is stop. In between, okay, what is the period that is used by that particular event, that can be captured by using this capture mode. Okay, in simple words we can say that. Okay, so this particular register is used for controlling for selection of mode for this CCP module. Okay, CCP1 control register, here 4 bits are given, and that decides the capture mode, compare mode, and PWM mode. Okay, that we will see. This is the CCP registers, higher byte register and lower byte register. Total register size is of 16 bits, and lower byte register is having 8 bits, and higher byte register is having remaining 8 bits of this CCP register. Okay, so let's start the discussing the registers which are used for CCP module in capture mode. Okay, so CCP1 con register, all of you know that this is 8-bit register. Only 6 bits of it are used for CCP module. The remaining 2 are reserved for the future use. Okay, out of these two big bits are used for PWM duty cycle. So these bits are not of our interest right now. So we will focus on only these 4 bits, CCPX M0 to CCPX M3 bit. These 4 bits are used for selection of capture mode, compare mode, and PWM mode. Let us discuss these bits. Okay, so here you can write the values for mode selection. If I write 0000, then CCP module is disabled. Okay, we are not going to use this CCP module for programming. Okay, if I want to use this in capture mode, I should write this value 0100 0101 0110 Here you can see capture mode every falling edge, 0101 capture mode every rising edge, 0110 capture mode every fourth rising edge, and next is 0111 capture every 16th rising edge. These four modes can be configured for capture mode of CCP module, which is available inside the PIC microcontroller. And other modes are related to compare, and PWM mode is the last mode. That by writing 1100, this particular mode can be selected, PWM mode. Okay, so these are capture modes. You can see falling edge we can select, rising edge we can select. According to this we need to write value. If I write zero, if I want to select falling edge, then here I can write what this particular value 0100. So here I will write 0000 This is the value becomes 4. So this 4 value can be used for falling edge mode selection, falling edge capture mode. Okay, if I write 5, then this rising edge mode selected will be selected. Okay, capture mode in every rising edge of the clock pulse. Okay, if I select 6, then capture mode every fourth rising edge. Okay, if I write 7, then capture mode every 16th rising edge is selected. Okay, so these are the capture modes which can be used for programming the microcontroller. Okay, now to avail this facility, okay, one interrupt flag is given inside the PIC microcontroller, that is called as a CCP1IF, CCP module interrupt flag. Okay, So this particular flag is raised to 1, okay, whenever you can see timer 1 or timer 3 register capture occurred at every falling or rising edge of the pulse as per user needs. So whenever the CCP1 IF flag raised to 1, that means event is occurred, event is happened, okay, across the microcontroller, okay, on the pin of this particular microcontroller PKTNF4550, okay, and we will store the values of timer 1 or timer 3 into CCP register lower byte higher byte, okay. If this particular flag bit is at 0, okay, then that means no event is occurred and timer will continue to work, or timer will continue to have increment until some capture event is occurred on falling or rising edge of the pulse, okay. So to avail this facility again, to use this interrupt flag, we need to enable this interrupt bit of this particular register, PIE register, PIE1 register. This is called as a peripheral interrupt enable register, and this is peripheral interrupt register, okay. So here this can be, again we can say that this is peripheral interrupt register for PKTIN F4550. This is peripheral interrupt enable register for PKTIN F4550. So this particular bit should be enabled by writing one value or logic 1 bit to this particular bit position, okay. Here I can write, so pi1 is equal to, I if I make this all four zeros and this particular bit 1, then this value will become 04. Again pi1 is equal to 04 I can write, so that this CCP1 interrupt flag I can use for capture mode, okay. So you should remember these two registers. All these are interrupt flags which are used for various purpose. This is timer 1, timer 2, okay, serial modes, okay, transmission, reception, okay, serial, synchronous serial communication. All these we can use for raising the condition, okay, that is set for picking microcontrollers, okay. So this is the first register that we have studied, CCP1 con register. Now timer 1 control register. This is 16-bit register. This is 8-bit register which which is used for controlling the 16-bit registers of timer 1. Okay, that is the control register. We can control the operation of timer 1, which is used or which can be used for capture mode of PKTN F4550. Okay, so these are the bits. You can see RD16 is used for making the or configuring this particular timer 1 as a 8-bit register or 16-bit register, okay. So here you can write logic 1 to select 16-bit register. We can access this particular register in one 16-bit operation, otherwise we can access in two 8-bit operations, okay. A single byte operation we can perform, okay, as a 2-byte register. So here you can see this PS1, PS0, these are pre-scaling options available. 1 has to 1, 1 has to 2, 1 has to 4, 1 has to 8. These are the pre-scaling options which are available inside the timer 1 control register for timer 1. Okay, that means what? FOC by 4, oscillator frequency is again divided by 2, 4, 8. Okay, to increase the timing of the timer 1, okay, in simple words. So this is, you can see, oscillator enable bit, timer 1 oscillator is enabled, timer 1 oscillator is shut off. Here you can use this timer 1 oscillator for running the timer 1, okay. This is the timer 1 synchronization, okay. So here this particular bit is only used when TMR timer 1 clock source bit is 1, okay, this particular bit, okay. Now what it means, because Here you can see this particular bit, that is timer 1 clock source. This particular bit, if I write 1 to this, then I will select external clock from this particular pin, RC0 T1 CKI, that will accept external clock signals. Okay, if I write 0, then internal clock frequency. If I use internal clock frequency, then this bit is not needed. Okay, this bit is needed only when external clock frequency is applied to this particular microcontroller pin, RC0 timer 1 clock input. Okay, so to run this particular timer 1 in synchronization, this bit should be written with 1 whenever this external clock mode is selected. So TMR CS bit is equal to 1, then we can use this timer 1 synchronization bit. Okay, that if I write 0, then this bit is not used. So only when this, only in external clock feeding, okay, this particular bit is used. Okay, and this is the first bit, that is the LSB bit. This is MSB bit. This LSB bit is timer 1 on. Okay, here you can start the timer 1 by writing logical 1 signal or 1 to this particular bit. Okay, so if I write 0, then this bit is cleared, or that means what, we are going to turn off this timer 1. Okay, so to you, if you want to turn on timer 1, then you should write logic 1 to this particular bit. Okay, so if I calculate the value for timer 1 control register with 16 bit mode, with 1 as to 2 prescaling option, with this particular timer 1 oscillator is enabled, okay, or disabled, simply disabled we will consider. Okay, timer 1 oscillator is shut off. Okay, here I can use TMR 1 CS bit 0. Here also I will use internal clock frequency, and here I need to turn on the timer. So initially this bit is 0, this bit is 0. Okay, this bit is again 0, I can write it. This bit is 0. Okay, here I have used 1 as to 2 prescaling option, 1 as to 2. Then here I can write 0 1, here 0, here 1. Okay, so what is the value we can calculate for timer 1 control register? 1 0 0 1, that means what, it is 9. 8 plus 1 9. So 90 is the value for timer 1 control register to use it in capture or compare mode in 16 bit operation, or with 16 bit operation in prescaling 1 as to 2. As per your needs, you can go for 1 as to 8. So here what value will become? 1011. Okay, so and zeros. So what this value will be? 1011. So 8 plus 2 10 and 11. So 0B value, B0 is the value for timer 1 control register to configure this capture mode with 16 bit operation and 1 as to 8 prescaling option. Okay, with the internal clock frequency FOC by 4. Okay, so this is all about timer 1 control register. Okay, now we have studied CCP1 control register, we have studied timer 1 control register, we have studied interrupt flag, which is used for CCP module, how to enable it, how to disable it, how it can be used, and if I want to generate interrupt, then which particular bit is should be enabled from the PIE register, that we have studied. Okay, now in the final stages we will see the steps which are required for programming the microcontroller in capture mode. Okay, so here you can see first step, which is very important for the capture mode selection, is initialize the CCP1 con register in capturing mode for rising or falling edge. 0405, these are the values for these two modes that can be selected. Okay, as we have already discussed. So in the next session, this particular pin CCP1 can be configured as an input pin. Okay, then if I am using timer 1, okay, then there should not be any configuration for timer 1 use, because timer 1 is default for CCP module in capture and compare mode. Okay, if I want to use timer 3, then I should use timer 3 control register to use timer 3. Okay, so this timer 3 will be used in a 16-bit mode, okay, with prescaling option and with clock source selection. Okay, so otherwise timer 1 is the default register. Okay, so here we will write the value for timer 1 control register, initialization value for timer 1 or timer 3 control register, T1 con or T3 con. Okay, for timer 1 and timer 3 selection. Okay, then here in the last stage we will set the CCP module in capture mode, and we will turn on the register timer register. Okay, so what this step is, here initial values for timer 1 16-bit mode is written with the value 00 and 00. Then I will turn on timer 1 or timer 3, okay, as per the user need, and I will wait for what, I will wait for this particular flag CCP1. Make timer on and monitor until it becomes 1. That means event is occurred or event is captured. Okay, so this particular flag will say this this particular event is occurred, or this particular flag will show the status of event occurred, okay, in the capture mode. Okay, so after raising this particular flag, user needs, when microcontroller raises this flag to 1, okay, user needs to copy the value of timer 1 or timer 3 to respective registers of the CCP module, okay, to get the time of the event occurrence. Okay, now we will see in the program what instructions we should write for enabling this capture mode. Here you can see tracebit.rc2 setting as a capture mode, okay, as a input. Okay, we will receive the input signal. Timer 1 control register is return value with B1, that is configuring this particular timer in 16-bit 1 has to 8 pre-scaling option. Again we can see this particular register here. Directly timer 1 is turned on. Otherwise, in the initial stages, this value should be B0. B0, timer 1 is 16-bit and 1 has to 8 mode. Okay. Then this particular mode is used for timer 3. Okay. This value is used for timer 3. And here initially we will clear this flag to check the status of the event occurred or not. Okay, and I will configure this CCP1 con register with 04 value for falling edge selection, 05 for rising edge selection. Okay, so 04, you should remember 04 CCP1 con is equal to 04, that is falling edge capture mode, and 05 is for rising edge capture mode. Okay, so here you can see these are the few steps which are related to compare mode. Now compare mode is nothing but same like capture mode. Here we are going to perform comparison, okay, of two values, and as per the result of comparison we are going to generate interrupt. Okay, compare mode we will discuss later. Okay, with this particular video I am going to give one example of program, or one program is attached with this particular video. Okay, you can go through it. Okay, so this is all about capture mode. Okay, in the coming session we will discuss compare mode. Okay, so this is all about capture mode. You can study it very well, you can program it very well. Okay, thank you very much.